Welcome. In this general chemistry tutorial, we'll look at writing a net ionic equation. We want to write a balanced molecular, ionic, and net ionic equation for the reaction of chloric acid and barium hydroxide. So we'll start with the molecular equation. We need to know the chemical formulas for chloric acid and barium hydroxide. Chloric acid is HClO3. Barium hydroxide is what we call dibasic, meaning that it has two hydroxides to balance the positive 2 charge of the barium cation. In this reaction, we have an acid and a base. A strong acid and a strong base will have a neutralization reaction, which is a type of double replacement. That means that the hydrogen is going to form a product with the hydroxide. The barium will form a product with the chlorate ion. So we end up with water and barium chlorate. We need 2 of the chlorate ions because they're negatively charged, -1. So we need 2 of them to balance the positive 2 of barium. We do need to add coefficients to balance this overall reaction. We place a 2 in front of chloric acid as well as water. To finish off the molecular equation, we add the states of matter. Our acid and base are aqueous, water is a liquid, and our salt, barium chlorate, is also aqueous. Taking that molecular equation and turning it into an ionic equation. In order to do this, any of the species that have an AQ means that they are dissociated into their ions. The 2 coefficient tells us we have 2 of each of those ions. So separating our reactants, I have 2H plus 2 of the chlorate ions. For the other reactant, we have barium 2 plus and 2 hydroxides. So this time the subscript told us we had 2 of the hydroxides. The subscript then becomes the coefficient when we list it as an ion by itself. For the products, we're going to leave water by itself. Don't change the formula because it's in the liquid phase. And again, we have an aqueous product. Split that up into its individual ions. Barium 2 plus and 2 ClO3 minus. Add states of matter. All of the charged ions are charged, have an aqueous phase. Water remains as a liquid. So that would be our ionic equation. From this point, we want to cancel out any spectator ions. Spectator ions do not participate in the chemistry. They are going to be the same formula on the reactants and product side. So what looks exactly the same on either side of the reaction arrow? Well, we have 2 of the chlorates on each side. We also have a barium on each side. Those are going to be our spectator ions, chlorate and the barium cation. So we would cancel those out. What's left is going to be our net ionic equation. We have 2 of the hydrogen ions, 2 hydroxides, yielding 2 water. You can further reduce this by dividing by 2. Our final net ionic equation is H plus OH minus yields H2O.